Hi everyone, my name is Andrzej, and in this video I'm going to talk about an example of Vega visualization. I will show you its Vega JSON specification and explain every element of the specification. I will start from Vega examples web page and a simple bar chart or a column chart. You can see here on the page with the example Vega JSON specification, and we can click View in Online Vega Editor link to open this specification in Online Vega Editor. When you will work with Deneb custom visual for Power BI, you will also be able to edit Vega specification inside of Deneb custom visual. I usually start from editing my code in Vega Online Editor, and only when I need to finalize this code, when I need to update some parts of the code that are specific for Power BI, when I need to connect my visualization to Power BI color schema, when I need to enable cross filtering and cross highlighting, I will edit this code in the Deneb editor. But most of the time, I prefer to use Vega Online Editor. Here in Vega Editor, you can see on the left JSON specification of this example. On the right side, you can see an image of the example. And on the bottom, we can switch between logs with some error messages or warnings about our code. Data view, where we will see all our data tables. Signal viewer, where we can see all our signals or constants and variables. And the data flow viewer, for me, is not really useful because it's just a lot of details in not a very usable form. So let me start from the Vega specification from the top of it. I rarely create a Vega specification from a blank page, so I'm not starting it like this. Usually, always there is an example that can be used as a base for more advanced visualization. For example, you can take this column chart and start editing this Vega code to make your own more advanced version of the visualization. You can add another element to the rectangles or bars on this chart. You can add lines, you can add whatever you want to make totally different visualization, but it's easier to start from some example. First line is always a reference to Vega schema JSON file. It will be the same in all your Vega visualization. The description property is just a description of your visualization for future yourself or for other developers who will work with your code. Just some explanation of what this visualization does. Also, you always can use user meta property. Inside of user meta, you can create your own custom properties. For example, copyright will be Andrzej. Website will be powerofbi.org. And you can add whatever information you want into the user meta section. For example, some comment. One will be whatever you want. Description and user meta, where you just put some description of your visualization, some links to external resources, just for better understanding of the visualization by future yourself or by other developers. Then we have width and height properties. Simple, they define size of our chart area. And we can increase it a little bit here, and we can increase it a little bit here. You can see now we have bigger chart. And let me make it the old size again. Padding is just white space around the chart area. I can increase it, and you can see that we have more white padding around the chart. I will make it 500 and 300 here. The next section of the JSON is data. Inside of the data object, you will define your data tables. In this case, we have only one table, which has name table, and the data is hard-coded inside of the values property. There are different ways to define your data. You can hard-code it using values property, and in the future videos with another examples, I will show you that you can use a link to an external CSV or JSON file here. Or when you will be connecting your visualization embedded into the Deneb custom visual to Power BI data, you will need to use dataset name, and there will be no hard-coded data and no links to external sources. This name dataset table will tell the Deneb custom visual that the data from Power BI has to be loaded into this dataset table. But for now, it's not Power BI and not the Deneb, so we can keep it as is and have just hard-coded values in our table. And you can switch to Data Viewer here, and you can see that we have table with two columns, category and amount. I can change something. For example, 38 instead of 28, and you can see the amount has changed in the data viewer. And it also has changed here on the chart. The next part of Vega specification is signals. Signals are constants and variables. You can define your own constants and variables here. Also, signals will be used to define how these variables react to different events for interactivity and animation. For example, here we have a tooltip signal or variable, which is by default has value an empty object, and there are two on under the on property there are two events. Events rectangle pointer hour and event rectangle pointer out, which means when pointer is hour any rectangle, the tooltip signal will be updated with datum, which is the data behind this rectangle. And when pointer is out of any rectangle, tooltip signal will be updated with an empty object. Let me show you. I will temporarily remove this row, pointer out, and when pointer is above a rectangle, so let me switch to signal view here, and you can see tooltip. So I selected this rectangle, and the value of the tooltip is the data behind this rectangle. This rectangle is based on category D, amount 91 data point. And it's not going to disappear now when I remove cursor from the rectangle because I removed the event pointer out. I can bring it back, and you can see the tooltip is empty object again because the cursor is not over the rectangle. And when I move cursor, you can see the tooltip has different values, depends on what rectangle is under cursor. The next part of Vega specification is scales. Here you can define one or many scales. Scale defines how your values will be projected onto the chart area, how values will be recalculated into the position on the area in pixels. For example, here we have two scales, X scale and Y scale. X scale has name, X scale is just you will decide how to name your scale. Just use some name that clearly explains what this scale is for. Type band means that this is categorical data. We have categories from A to H. So the next property is domain, and domain actually connects our scale to the data table and to the field inside of this table. So domain will be based on data table named table and the field category from our table named table. So we have table and we have category. The next property is range. Range width means that this data from this domain will be scaled to be distributed through the entire width of our chart area. So we just taking these 8 categories and distributing them through the entire width of our chart. Next element, padding, is this white space around our rectangles. When it's 0, there is no white space. You can use it to create some histograms where usually we don't need white space between the columns. Or you can increase it to have bigger white space. When it's 0.5, it means that we have half of the category width around our rectangle from each side. So in total, between two columns, we have a space the same that the category, the rectangle actually in this category takes. Let's keep it 0.3. And round means that once our values have been recalculated into X and Y positions, they will be rounded to keep integer values of our positions of our elements on the plot. So it won't be 50 point, a lot of digits after the point pixels. It will be just rounded integer values. The next scale is Y scale, is for Y axis. It uses again table and field amount. Nice, true means that the values will be rounded to some nicely looking values. Like you can see in the table that the largest value is 91, but we don't have the scale that ends on 91. We have the scale that ends on 100 to make it nice. And the range height means that the entire range of our values from our domain will be distributed through the entire height of our chart. Then we have axis section where we can define one or more or 0 axes. It's just visual representation of our scale. We can remove both axes and you can see that we don't have any labels on the axis anymore. But we still have the scale that defines how our values being projected into the chart area. So axis part is only for visual elements of the axis like labels, tick marks, and domain lines. You can add additional elements actually to this definition of the axis. For example, first axis says orient bottom, so it will be axis on the bottom, and it's based on X scale. And you can define some additional properties here. For example, ticks false will remove the tick mark. Domain false will remove the domain line. Labels false will remove the labels. Or you can keep the labels, but use another property to change, for example, font size. It can be 20. You also can change label font. You can change font family. I don't recommend to use Times New Roman. It's just the font that you can easily see that the labels have been updated to use Times New Roman font. You can change label color. You can use some word names here, or you can use numeric values for the colors. Let's remove Times New Roman, but keep font size and color. Also, in the editor, you often will need to use Shift-Alt-F combination. It's a shortcut for the command that properly formats your JSON. You can see that I can do something like this, add space here, and then I click Alt-Shift-F, and it's properly formatted, easy to read JSON. It's a different combination in Deneb, so you will need to get used to it, that you need to use two different combinations in Vega editor and in Deneb. Here in Vega editor, it's Alt-Shift-F. Then we can do the same for the second axis. We can just probably copy properties from here, insert them into the description of another axis, and you can see the same format of the labels. The next section is for marks. Marks are our main elements of any visualization. It's actually elements that use it to encode our data. In this case, rectangles or columns. So we have mark for rectangles type rect, and we have another mark here, which is type text for the labels above the columns, but they visible only above the selected or red column. So what we have here inside of marks property? First of all, we need to define type. Then we define from what data table we use the data for this mark. This mark will use data table, and it means that a mark, or in this case a rectangle, will be created for every row from table named table. Then we have encode section, which encodes additional properties of our rectangle. So it always be encode here, and then you have choice between enter, update, hover, sometimes exit. Enter. To simplify the explanation, enter you will use always when you have elements that have to be generated only once, and their properties won't be updated during any interactivity events. So, for example, we created this rectangle and it will remain on the same place always. So its X position, Y position, its width, it will remain the same, so it needs to be generated only on enter, or only when we generate this chart first time. But the fill color of the rectangles is going to be changed with the cursor movement events. So we will need to write it under the update property, not under the enter property. And for hover, there is a hover property here. So what happens when cursor is our marks is defined here. Let me go into the enter. So we have x is where we define x position of our rectangle. It will be top left corner of our rectangle. Its position will be defined by scale, x scale, and by the field category. So it depends on our category. Our scale distributes categories from A to H through the entire area. And it means that category A will be here, category B will be on its place, and so on. Width property defines width of the rectangle, and also it's based on x scale, and band 1 means that it will be through the entire place defined for this category, except that we have some padding around our rectangles. So you can change band to 0.5 and it will make rectangles half of the size that they were before. Instead of using band, you can remove the scale and band from here, and you can just use some hard-coded value 50 pixels or 20 pixels. Let me restore. The same is for Y position of our rectangle. The Y position is defined by Y scale and amount field. So amount field on our Y scale will define Y position of the rectangle. Again, it will be top part of our rectangle. It starts from top, and the Y second will define the bottom of our rectangle, and it will always be 0 value. It's 0 value, but not 0 position in pixels, because 0 point in pixels on our chart area begins here on the top left corner. So our scale converts 0 value from our domain, from our table with data, into the position in pixels, which will be the entire height of our area. I think it was 300 pixels. So Y2 position is going to be 300 pixels because our 0 value is on the bottom of our chart. What is very useful to have, you will need to use it in more advanced visualizations. You can name your marks. You can add name property here. And I usually use prefix that defines type of my mark, and then I give it some name. In this case, is just column. When you added a name property to your mark, it appears here in Data Viewer as another table. This table always created by Vega, but behind the scene. If you don't have the name here, you have no access to this data table. So I recommend always to name your marks so you have access to the table which is used by Vega to generate the visualization. And you can see here X, width, Y, Y2, height, all properties of our rectangles in pixels. So you can see that X position for category A is 19 pixels. 19 pixels from the left border of our chart area. So X scale was used to convert a category name into the position, which is 19 pixels. Y scale has been used to convert our amount, which is 38, into 186 pixels from the top to the top of the chart to the top of the rectangle. So you can see for the bigger value, which is amount 55, we have 135 position in pixels from the top. This is very useful, so I recommend you to always name your marks if you want to understand what is happening behind all these scaling transformations. Then we have update property, which defines that our rectangles will be fill property with steel blue color. Again, you can use numeric representations of colors here, or you can use some names. And hover says that on hover event, when cursor is over the rectangle, the color of the filling will be changed to red. You can see it's red, and when it's not about the rectangle, updates our fill property to steel blue. If you will put this fill value steel blue under the enter, not under the update, you can see that its hover makes it red, but then when I remove cursor, it remains red, because there is nothing in update, and enter works only once when the chart is generated first time, so it's not going to be updated once again. So if you need this kind of interactivity, you need to put it under the update. And the second and the last mark in this visual has type text. So we need to display these labels, and we want them only to be visible under the selected red column. So we have type of our mark text, again encoder and enter, where we have align for horizontal aligning of our text, which is center of the category band. We have baseline, which is vertical alignment, which is bottom of the text. We have fill color, which is gray. And then under the update, because we need this to be interactive, dynamically changing, we have X position of our text, which will be defined as by X scale, and our signal with tooltip, which is an object with two different elements. So we use tooltip category. Let me remind you that look here at tooltip, and I will select a column, and you can see that category D amount 91 is values inside of our tooltip object, and we can call tooltip point category to get name of the category. So we check using our X scale where is our category A position in pixels. So it returns us position in pixels, which is again will be beginning of this category, and then band 0 point shifts our text to the middle of our category, our band for the category. If I will change it to 0, you can see the text is on the left side of our rectangle. The band 0.5 just shifts position of the text into the middle of the rectangle. Then we have Y position, which again is based on Y scale, and the tooltip amount value or amount behind the selected column. Offset -2 just shifts this text 2 pixels above the column. Minus because we have 0 pixels here on the top position. So if we are using -2 pixels, we are moving our text to the top of chart area. You can see I can use -20 pixels and it's about, now it's 20 pixels above the rectangle. And then the text will be, again, from the tooltip object, we will take amount, which is 39 for this column. Fill opacity changes text opacity, but in this example, I don't think we don't even need it here. We can remove fill opacity and the same functionality remains, because when cursor is not over the rectangle, our tooltip object is empty, and therefore X position of the text is not defined, Y position is not defined, it will be 0, 0 actually, and the text will be blank because there is nothing in the tooltip object. So there is no text when the cursor is not over the rectangle, so we don't even need to change opacity of our text in this case. If you want to make the labels always visible, you can update this code a little bit. For example, you won't need this update section. You can merge it with enter. Then X position of the text will be defined by category field. Y position of the text will be defined by amount field. And the text let me show you something. You can use value here. Then you can type anything here. And you can see that the text is in 0, 0 position because we never defined the data object for our text mark. You can see that our marks are based on table, but our text is not linked to any data table, so text position is 0, 0. There are different ways to link your text to the data. You can link it to the same table that your rectangle marks, or you can link the text mark to the rectangle column mark. Let me show the simplest way for now. So now our text mark is linked to the table. Therefore, we have data. We have 8 rows in the table. So this text mark will be generated 8 times instead of just 1 by default. When you have no data object linked to a mark, it will be created only once. When you have data object, then it will be created for every row in the table. So now the text created for every row in the table, but it's hard-coded value because I just typed value here, and you can replace it with field amount to get our amount here. There are also different ways how you can address your fields from the data table. So you can use this field property and write amount here, or you can write signal, and then you will need to use datum point before amount. So this is another way to address your amount field from the table. It's either signal and then datum point amount, or it's just field amount. And when you have signal here, you can write actually any calculation, some formula inside here. So it can be some text. I can add space here. And you can see this text above the columns. Another thing you will want to do with your Vega code, at some point you will want to replace all hard-coded values for colors, probably for font size, for other values. You will want to use some constants to define these properties. So you will need to create signals. For example, we have fill color. Let's go to our rectangles. We have fill color still blue. But we want to use a signal to define this color. We need to change value to signal here. And instead of still blue, we will use signal name, which will be rectangle fill color. Then we need to create this signal. We go back to the signals and we can add new signal. Signal, rectangle fill color, and value will be, so our signal rectangle fill color has value green. It's our constant which can be reused anywhere in the code. And you can see that here we can call this signal to get value from the signal into the fill property. We can do the same for the labels color, for example. We have color here. Again, we need to, when the property is value, it will be hard-coded value here. When it's signal, you can use some formula for calculation. You can address an existing signal. The same you will want to do probably for font size, for the labels. In this case, again, to replace hard-coded value, you need to call it like this. Signal, label, font size, unrecognized signal name, because there is no signal, label, font size. We need to create it. Again, we can go to the signals and we can add one more signal, which will have name, label, font size, and which will have value 22. In this way, you can just replace all hard-coded values with signals. So when you will want to change formatting of your chart, colors, font sizes, and so on, you don't need to scroll through the entire code and to search for the hard-coded values. You will just have signals on the top, which you can edit to change all formatting settings of the entire chart. That's all for beginning. I will continue in the next video with more advanced examples of other visualizations created using Vega. And at some point, I will go into Power BI and will show you in the Deneb visual how we connect Vega visuals to Power BI data, to Power BI color schema, how we can enable cross-filtering and cross-highlighting, and so on. For now, that's all. You can try to edit your first Vega visualization just by making some changes in simple bar chart example from Vega examples web page.